So welcome back to the Java OCP 21 series. I am Oru from ClusterMicro Technologies. So in the previous video we covered period and duration, how they differ, which classes they are compatible with, and the critical chaining trap that catches most candidates off guard. In this video we are covering instant, the third time amount concept in the Java.time API, and one that is conceptually different from everything we have seen so far. Okay, so local date, local time and local date time are human readable representations of time. They give you a year, a month, a day and year. You can look at them and understand immediately. Instant is different. Instant is a machine's view of time. It represents a single point on the UTC timeline measured as the number of seconds and nanoseconds that have elapsed since a fixed reference point called the epoch. It is not human readable in the traditional sense. It is precise, unambiguous and time zone independent, and it is what you use whenever you need to record or compare exact moments in time, log entries, transaction timestamps, API responses, database records. Okay, so the OCP exam tests instant specifically around these three things now. The OCP exam tests instant specifically around three things. Okay, so how to create one, how to do arithmetic on it, and how to convert between instant and ZonedDateTime. So let us go through all three. Okay, let's move to slide 2. So creating an instant. Okay, so before we look at the code, let me explain what an instant actually represents at the technical level. Because once you understand this, everything else about instant makes sense. Okay, the epoch is a fixed reference point in time, midnight on the 1st January 1970 in UTC. So this date was chosen as the universal reference point for computer time by the early Unix developers, and it has been the standard ever since. An instant stores a single value, the number of seconds that have passed since the epoch, plus a nanosecond adjustment for sub-second precisions. If the instant represents a moment before the epoch, before 1970, the seconds value is negative. Okay, so there is no year, no month, no day, no hour stored explicitly, just a count of seconds from the epoch. This is why it is called machine time. It is a pure number that a machine can work with directly, without any human calendar concepts involved. Now let us look at three ways to create an instant. Okay, so in the first block, instant now equal to instant.now, instant epoch equal to instant.epoch, and then instant fixed is equal to instant.epoch second, then 100,000 L. Okay, so instant now equal to instant.now is the most common way to create an instant. It captures the current moment in time as a UTC timestamp. Behind the scenes, Java reads the system clock and records the number of seconds and nanoseconds since the epoch at this precise moment. Okay, so when you print this instant, you will see something like 2025, then 03, then 25T, 10, 30, 15, 1, 2, 3, 4, 5, 6, 7, 8, 9, Z. Okay, the Z at the end is critical. It stands for Zulu time, which is the military designation for UTC. Anytime you see a Z at the end of a timestamp, it means UTC. No offset, no daylight saving. Okay, this is what you use in applications when you need to record exactly when something happened. When a user logged in, when a payment was processed, when a log entry was written. Okay, then in the line 2 we have instant epoch equal to instant.epoch. So instant.epoch is a constant, a predefined instant object representing exactly epoch moment. Okay, exactly the epoch moment. Midnight on 1st January 1970 in UTC. Its value is 0 seconds from the epoch. When printed, it displays as 1970 0101 T00000 Z. Okay, so this is useful as a reference point or as a baseline of calculations. The exam occasionally uses instant.epoch in questions to test whether you know what it represents. Okay, and in the line 3 we have instant fixed equal to instant.epoch sound. So you can create an instant in three ways: instant now equal to instant.now, then instant epoch, instant.epoch, and instant fixed equal to instant.epoch sound 1 million L. Okay, so the first line is instant now equal to instant.now within bracket, with a bracket. So this is the most common way to create an instant. It captures the current moment in time as a UTC timestamp. Behind the scenes, Java reads the system clock and records the number of seconds and nanoseconds since the epoch at this precise moment. Okay. So when you print this instant, you'll see something like 20, 25, 0, 3, 25, T, 10, 30, 15, 1, 2, 3, 4, 5, 6, 7, 8, 9, Z. Okay. The Z at the end is critical. It stands for Zulu time, which is the military designation for UTC. Anytime you see a Z at the end of a timestamp, it means UTC, no offset, no daylight saving. Okay, so this is what you use in applications when you need to record exactly when something happened. Okay, when a user logged in, when a payment was processed, when a log entry was written, etc. Then in the second line, we have instant epoch equal to instant.epoch. Okay, so instant.epoch is a constant, a predefined instant object representing exactly the epoch moment midnight on 1st January 1917 UTC. Its value is 0 seconds from the epoch. When printed, it displays 1970-0101 T0000 Z. Okay, so this is useful as a reference point or as a baseline for calculations. The exam occasionally uses instant.epoch in questions to test whether you know what it represents. Okay, and the third line is instant fixed equal to instant.epoch sound 1 million L. So of epoch sound is a factory method that creates an instant from a specific number of seconds after the epoch. Okay, so we are passing 1 million L, 1 million seconds after the epoch. The L suffix makes it a long literal, which is required because of epoch sound second takes a long parameter. So 1 million seconds after midnight on 1st January 1970 is approximately the 12th January 1970 at 13:46:40 UTC. Okay, so there is also an overload instant.epoch sound, then within brackets seconds comma nano adjustment, where you can specifically subsecond the precision, and instant.epoch milli, then within bracket milliseconds if you are working with millisecond precision. Okay, so which is common when dealing with legacy system or JavaScript timestamps. Okay, then the second block of code is instant later equal to now dot plus duration of hours to and instant earlier equal to now dot minus duration of minutes 30. Okay, so now that we have instant, how do we do arithmetic on it? Okay, so how do we go forward or backward in time? So instant supports the plus and minus methods just like local date and local date time, but there is a critical restriction here. Okay, instant only works with duration, never with period. So if you see the first line, instant later equal to now dot plus duration of hours to, so we add a duration of 2 hours to now. Okay, so duration is time based, hours, minutes and seconds. Instant is also time based. It is a count of seconds from the epoch. They are compatible. Okay, the result is a new instant representing 2 hours after now. This compiles and run correctly. Okay, and then in the second line we have instant earlier, now dot minus duration dot of minutes 30. So we subtract a duration of 30 minutes from now. Okay, so again duration and instant are compatible. The result is a new instant representing 30 minutes before now. Okay, and then in the third line we have the red line, actually the instant dot plus period unsupported temporal type exception at runtime. Okay, so why can instant not use period? Think about what period represents, right? Years, months, days. So those are calendar based units. To add 1 month to a date, Java needs to know which month we are in. Okay, because different months have different number of days. To know which month we are in, Java needs a date construct, a year and a month. Instant has no date context. It is just a count of seconds from the epoch. So it has no concept of which month it is in or how many days that month has. Okay, so when you try to add a period to an instant, Java cannot do the calculation. It throws unsupported temporal type exception. Okay, so now this is a runtime exception, not a compile error. The code instant dot plus, then some period will compile. The compiler does not catch this. Okay, so it only fails at runtime when Java tries to execute the addition and discovers it cannot. Okay, this is an important distinction for exam questions that asks whether code compiles or throws an exception. Now we move to slide 3. converting instant and zone date time. Okay, so we have established that instant is a machine time, a UTC timestamp with no human calendar concept. Okay, but in real application you often need to convert between machine time and human readable time. So you receive a timestamp from a database or an API. That is an instant. You need to display it to a user in their local time zone. That requires a zone time, or you receive a zone date time from user input and need to store it as a UTC timestamp. Java gives you two methods to convert in both directions. Let us look at them. Okay, so the first line says ZoneId zone equal to ZoneId dot off Asia Kolkata. So ZoneId represents a time zone. ZoneId.off takes a time zone name in the IANA format, the standard format used globally for time zone identifiers. So Asia/Kolkata is Indian Standard Time, which is UTC plus 5 hours and 30 minutes. The format is always region/city. Common ones that appear on the exam include America/New York, Europe/London, Asia/Tokyo, Asia/Kolkata. So you pass the full string exactly as shown, case sensitive, which is with the /. Okay. Then we have zone date time ZDT now equal to now.addZone zone. So addZone is called on the instant and takes a zone ID. So it attaches the time zone to the instant, converting it from machine time to human readable time in the specified zone. Okay. So what this does internally is take the UTC timestamp stored in now and calculate what date and time that corresponds to in the Asia/Kolkata time zone. Okay. Since Kolkata is UTC plus 5 and 5.5 hours, if now was 2025-0325, then T05 then 00Z in UTC, then in Kolkata time that would be 2025-0325 T 10:30 plus 05 :30 Asia Kolkata. Okay, the ZDT variable now holds a zone date time, a full date, time, offset from UTC and time zone name all together. Okay, so this is human readable and time zone hour. Then we have instant back equal to ZDT dot to instant. To instant is called on a zone date time and strips the time zone information away, converting back to a pure UTC timestamp. The result is an instant representing the exact same moment in time, just without the time zone annotation. Okay, so back should be equal to now and they represent the same point in time, just expressed differently. Adding a time zone and then removing it gets you back to where you started. Okay, so this round trip, instant, then add zone, then zone date time, then to instant and then to instant is a very common pattern in real applications and appears in OCP exams also. So know both directions. Add zone goes from instant to zone date time and to instant goes from zone date time back to instant. Okay, so next we have 5 lines basically. Instant A equal to instant dot now, instant B equal to instant dot now. Then we have system.out.println A dot is before B, then system.out.println A dot A is after B, and system.out.println A dot compared to B. Okay, so if we see instant A equal to instant dot now and instant B equal to instant dot now, so we create two instances by calling now twice in sequence. Okay, because A was created before B, so A represents an earlier point in time. Okay, even if only by microseconds, the two instances are different. Then we have system.out.println A dot is before B, so it will be true. Is before returns a true if this instant comes before the argument. So A was captured before B, so A is earlier in time, so A dot is before B returns true. Okay, then we have system.out.println A dot is after B, so it will be false. A is after returns true if this instant comes after the argument, so A is earlier not later, so A dot is after B returns false. Then we have system.out.println A dot compared to B, so it will print a negative number. Compared to follows the standard Java comparison contract. It returns a negative number if this instant is before argument. Okay, 0 if they represents the same moment, and a positive number if this instant is after the argument. Okay, since A is earlier than B A dot compared to B returns a negative value. These three comparison methods, A is before, is after, and compared to, are the standard ways to compare instant objects. You should never use equal to, equals to compare instance that compares object references, not the timestamps they represent. Always use before, is after, equals, or compared to for value comparison. Okay. So you have to remember three things here. First is instant represents a single point in time as a UTC timestamp, seconds and nanoseconds from the epoch. That is 1st January 1970 midnight UTC. It is a machine time, not human readable directly. No date, no time zone, just a count from the epoch. Create it with instant.now, instant.epoch, or instant.of epoch second. Okay. Second is instant works with duration only. Okay, not period. Adding a period to an instant throws unsupported temporal type exception at runtime. Note, this is a runtime exception, not a compiler error. The code will compile, but it fails when executed. And then convert between instant and ZonedDateTime using add_zone and toInstant. Instant.addZone zone adds a time zone and gives you a ZonedDateTime. And ZonedDateTime toInstant strips the zone and gives you back an instant. These two methods form the bridge between the machine time and human readable time in your application. Okay, so compare instant objects using is before, is after, compared to, or equals. Okay, never use equals. So thanks for your time. See you in the next video. If you got value from this video, please like and subscribe. It genuinely helps this series reach other OCP candidates who need it. Okay, so if you want to practice OCA questions right now, you can go to javalearn.clustermicro.com. Over 1600 questions are there, and they are timed exams, detailed explanations, and free trial available. So OCP 21 practice questions are also coming soon. You can email ab.clustermicro@gmail.com if you want early access notification. So I'll see you in the next video. Thanks for your time.